The first columns to consider are your primary key columns. The good news is that you do not need to do anything with these columns, as Oracle will automatically create a unique index for each primary key. The only action that you might want to take is to supply a meaningful name with your primary key, either in the create table or the alter table statement, whichever way you create the primary key on a table. If you don't supply a name, Oracle will create a system-generated name that starts with the characters SYS. I myself like to have my primary keys have a more meaningful name, and one of the reasons for this is because it makes execution plans easier to read. As a side note, make sure that each of your tables has a primary key defined. This is strictly more of a data modeling issue rather than a performance issue, but it will save you trouble down the road. One good reason for this is when it comes time to perform an update or delete statement against a row of data, you want to be using the primary key as the criteria in the where clause. First of all, this assures that you'll only impact your intended row, but also because the primary key is a unique index, these operations will be completed very quickly. If there is not a natural key on the table to serve as a primary key, then create a surrogate key for the table using an Oracle sequence. In the long run, you will be glad that you did, as overall it just makes the table much easier to work with. The next set of columns you want to consider are any columns that contain unique values in your database. These could be items like username, an email address, or a combination of columns, like the combination of a student and a course offering, which makes sure that a student can only enroll in a particular course once per semester. You want to create these unique indexes on these columns for a couple of reasons. First of all, you want to enforce uniqueness on these columns at the database level, and this is a good thing. You may enforce uniqueness at an application level as well, and you probably should. But by enforcing this constraint at the database level, you can be absolutely certain that no duplicates will exist. Secondly, you will often find yourself querying data out of the database using these unique values. For example, when you need to authenticate a user, you are usually looking up that user by their username or their email address, not some sort of numerical user ID. So there's often a good overlap between these unique columns in your database and some of the query requirements your application has. So go ahead and create unique indexes on these columns. The next step you should look at is to index the foreign key columns in your database. There are two reasons for doing this. First of all, these columns are going to be used in any join operations between two tables, and so you want an index so that Oracle can efficiently perform these joins. Secondly, I often find that many of my queries will follow along the lines of foreign keys between tables. For example, in the table shown here, it is likely we'll have some sort of function in our application to find what courses a particular student is enrolled in. So an index on the student ID column in the course enrollments table makes sense. Further, a second index in the course enrollments table over the course offering ID column also makes sense, because it is likely we'll want to have some sort of function to list what students are enrolled in a particular section of a course. So what you will find is that if you get all of your foreign key columns indexed, this will provide a good base for indexing your application and the types of queries that you'll end up running. The final aspect to look at is the aspect that is also the most important, and that is what columns are commonly used in your where clauses when querying data. This is where knowledge of how the application works and how data is used by the application is really critical, because you can use this knowledge to identify how the application will need to extract data out of the database. So you'll be able to take these criteria that your application queries data by and identify the corresponding columns in the database, and these are the columns that likely should be indexed. I always pay special attention to date columns as well when indexing a database. A lot of data ends up being queried by a date range, so it is often important to have some good indexes on a date column in a table. If we think of the canonical customers orders database, we probably aren't just getting all of the orders for a customer, but we're probably getting all of the orders for the customer over some date range, whether this is in the last week, the last month, or the last year. So take a look at your date columns and understand how these fit into your application and how your users ultimately want to query your data using these columns. Once you start identifying the columns that need to be indexed for a table, you'll want to see how these columns fit in with the indexes on the foreign keys you've already created. Oftentimes, you'll be querying a table by the foreign key values and some additional criteria. So in this case, you want to add those additional columns to the index you created on the foreign key columns, not create a separate index. As you go through this process, you want to identify clusters of columns that are always used together to query a table, and then what additional criteria are provided some of the time. Columns that are always used to query a table should be grouped together into a single composite index, and then you can add the additional, less frequently used columns at the end of these indexes. In doing this, you should start to see patterns emerge in your indexes about how the user will want to access data, and these patterns should match what you have in your application. At this point, you should have a good foundation for the indexing strategy of your database. What you will want to do from here is to take some of the critical SQL statements from your application and generate execution plans for these to make sure that they're using the indexes that you've just created, or if there's any fine-tuning that you need to do. Ideally, you would generate an execution plan for every SQL statement your application runs. Unfortunately, as we all know, there always seems to be too much to do and not enough time to do it in, so you'll probably need to prioritize the statements you look at. How do you prioritize the most critical statements in your application? These would be SQL statements that run against your largest tables, are in your most critical business functions, or are the most complex SQL statements in your application. For example, if you have a statement that is doing multiple joins or involves a subquery, that is a statement you probably want to get an execution plan on. Looking at these execution plans, you'll be able to determine how well your indexes match up with these statements and make any adjustments as needed. Performance tuning is often an iterative process, so don't be afraid to try something out at this stage of development. After a few of these iterations, you'll be able to settle on what is the best indexing strategy for your database.